All right, let's move into our next section here as part of Domain 5. This is a big section and actually quite technical. We will be discussing all different kinds of identity management implementation platforms. We'll start with the basics, password management. Most common authentication technologies today use some sort of password management. We have policies in place, we have standards, we have complexity that's associated with password use, and that needs to be managed in a consistent way in the enterprise, right? And everybody watching this video probably has a general understanding of what most enterprise password management platforms include, right? You know, you need to periodically change your password. The password has to have a certain level of complexity and whatnot. Most modern systems require users to change their password on a pretty regular basis, right? Not only that, we'll keep an archive, if you will, of previously used passwords, and we're not going to allow you to use those passwords in when you're establishing your new password. All right. Certainly, it's the most common authentication technology used today. Kind of the most widely used method for verifying a user's identity across systems. We know that there are a lot of vulnerabilities that deal with passwords, so oftentimes we'll incorporate the use of multi-factor authentication as part of a secondary, compensating control to address some of the weaknesses of standard password management. But even with the rise of multi-factor authentication, passwords are kind of foundational, especially if you're dealing with things like legacy systems, basic web applications, or even if you're dealing with like the initial authentication layers. They're ubiquitous, right? And that ubiquity makes them also a prime target for attackers. Anything that's ubiquitous typically results in that being a prime target for attackers. All right. And that's why password hygiene is so critical in most enterprises. Policies, standards, complexities have to be associated with a password to be, and that policy needs to be consistent throughout the enterprise. You have to enforce a uniform password policy across all platforms so that you don't have gaps in your security. Inconsistent enforcement, if you're not enforcing strong complexity rules on your internal systems and you have weak rules, but maybe you use strong rules in the cloud or something like that, that obviously introduces exploitable weaknesses in the enterprise. Centralized identity management, Active Directory, cloud-based identity and access management solutions are what we're going to use to ensure consistent enforcement of password policy, which includes password length, character requirements, reuse restrictions, and so on. It's absolutely important that regular password changes take place. That's going to reduce the risk of long-term exposure if for some reason credentials get compromised. Now, NIST, the National Institute of Standards and Technology, kind of discourages arbitrary password expiration, but periodic changes are still useful if there's a suspicion of compromise or if you're operating in a high-risk environment. You need to be able to balance the frequency with use fatigue, right? Meaning, if you force monthly changes or even weekly changes or whatever it might be, if it's often periodic or if it's quick, right, that's going to probably force users into what we refer to as predictable patterns. All right? We do have most modern systems that are configured to require users to change their password at a defined interval. I don't want to suggest that that's not something that happens because we have password expiration policies, which means that users have to update their credentials after that time frame, right? This can be implemented through GPOs in a Windows environment or some sort of identity and access management solution in the cloud. Could be 60 days, could be 90 days, could be 180 days. Again, that's probably going to be determined based on the sensitivity of the system and whatever regulatory requirements might exist. All right. If passwords are compromised, we need to limit the amount of damage that's done through that compromised password, right? The damage window gets limited to how long that password might remain valid. So let's say, example, a user's password gets compromised, but the system forces a change every 30 days. That means after that 30-day window, they're automatically revoked. Now that doesn't sound great, right? Especially if you're on day one of the new password, you're essentially allowing that user access, that attacker access to resources for 29 days. So there needs to be other mechanisms, right? The shorter the length is better for security, but longer is more convenient for users, right? Classic usability versus security trade-off. Frequent changes often lead to poor practices, writing passwords down, using incremental variations like summer 2024 1, summer 2024 2, summer 2024 3. But again, we can use MFA to mitigate those potential threats. All right. The optimal time to expire passwords will be a compromise between business needs and security needs. For example, a healthcare organization that's subjected to HIPAA might enforce stronger expiration policies than a startup company that has minimal compliance requirements. All right? That should factor into your threat models, your user roles, and the presence. We talked about this in domain number 2, compensating controls. Multi-factor authentication being a perfect example. All right? Or even behavioral analytics, looking at what happens with users based on their behavior. Okay? All right. Users with multiple passwords, multiple systems, expiring on different dates tend to write them down. They put them in a file called password.txt, or they'll put them on a sticky note or whatever, right? So it's a direct consequence of cognitive overload, right? Without having centralized identity, without having single sign-on, users could end up with 5, 10, 15 different credentials. So a sticky note under the keyboard or a password file on the desktop becomes more possible, right? And attackers know what to look for in these cases. We can set the same password for different systems, but here's the problem with that. If that password is compromised, right? If one system is breached, those reused credentials can now be used across other platforms as well. Okay? Rotational patterns are common as well. Like I said, summer 2023, summer 2024, summer 2025. Those could be easily cracked, with some sort of dictionary-based attack. Password uniqueness, password entropy is definitely something that you have to consider. Okay? You can choose password management software products for the purpose of managing, but we need to set and use multiple unique passwords. So what they're trying to say there is, if I have to have multiple passwords, utilizing a password management application like LastPass or Bitwarden, 1Password. These are what we call password vaults. They're encrypted vaults. They get integrated with IAM platforms, and that reduces your reliance on memory, and it eliminates insecure password storage practices, right? They can bridge also in a hybrid environment, a cloud environment, on-prem, and so on. We need to be able to protect against attackers trying to guess passwords. So we have lockouts, maybe after a couple of attempts, 5, 10 attempts. That will stop what we call brute force attacks, but those have to be tuned very carefully. If it's too aggressive, the attacker can actually trigger a denial of service attack by locking out legitimate users. All right. So some systems will actually use what we call progressive delays, meaning, like an iPhone, right? When you log into the iPhone incorrectly, it locks it out for a minute, and then it locks it out for 10 minutes, and then it locks it out for an hour, and so on. Or you might use a CAPTCHA option or something like that. Lockout mechanisms are important because they reduce the risk of unauthorized access by guessing passwords by limiting the number of login attempts. We call this just simply rate limiting. Now, if we combine that with logging and alerting, this means that we can detect and contain credential-based attacks. All right, that can feed into a SIEM, a security incident and event management platform. We can implement SOAR playbooks, security orchestration, automation, and response playbooks in response to these alerts, and that can protect security as well. All right. Help desks consistently report that password resets are the most common form of support request, right? So that kind of lends itself to this idea that password-based security or password-based authentication not the best option. All right? So you can provide things like self-service reset portals, multi-factor authentication backed recovery. So if somebody needs to reset their password, we can at least have some security. You can use passwordless strategies like Windows Hello, FIDO2 is another example, and that will help reduce that burden as well. All right. A centralized password management system means that you're going to have consistent enforcement of the password policies, of practices across your entire enterprise. This includes lifecycle management, the creation, the expiration, the reset, the policy enforcement with length and complexity, the integration with identity providers. All right? All right. Account management. Organizations use a lot of time and effort in managing accounts, right? When they're creating system access, managing accounts, onboarding, role changes, offboarding, it's going to take a lot of time. There has to be coordination with different entities. There are resources across different departments that have to be managed, right? So think like HR is triggering a new hire, or IT needs to provision accounts. Managers might be requesting access changes. All right. Security needs to mean that we're doing timely revocation. Any delay or misstep or misconfiguration will end up in something called privilege creep, where somebody ends up getting more access to resources than they're supposed to have. You can have a bunch of orphaned accounts. There's insider risk. So you can use automated workflows with IAM platforms. Okta or Azure AD helps streamline the life cycle. All right. Most organizations are heterogeneous. They have different versions of systems and different applications. They have different account management strategies and so on. So we operate a mix of legacy systems, cloud platforms, third-party applications. They each have their own access control model, their own management tools. So a hybrid setup could include things like Windows AD, AWS IAM, Salesforce, even legacy ERP systems. If you don't have centralized governance, managing accounts across those individual silos becomes more prone to errors. Federated access, OIDC or SAML, SCIM-based provisioning can help unify these platforms together and so on, right? So account management processes, we're typically doing this on each system directly. In a lot of different environments, user accounts are manually created, all right? Or modified or removed, whatever it might be. But it's done on each individual system. That's clearly an operational inefficiency. And it also will most likely result in inconsistent policy enforcement. All right. For example, a user might be disabled in Active Directory, but they're still active in some sort of cloud SaaS application. So having a centralized identity orchestration tool can help push out updates across all the systems. That's going to reduce your manual touch points. That's going to improve auditability, accountability, and so on. All right. Centralized access, right? A centralized access management solution, last bullet point here. Well, second to last. This is going to give the administrator control over permissions across lots of different systems from a single interface. What does that do for us? That ensures policy consistency, enforcing least privilege or role-based access control across on-prem and cloud environments. It's also going to simplify compliance reporting. It's going to help with incident response and so on. So automating account provisioning is going to not necessarily eliminate, but it's going to reduce human error, which could potentially lead to users receiving incorrect access or excess access and so on. Mistyped usernames, misassigned roles, forgotten deactivations. If you're using a manual workflow, these are the kinds of things that can occur. Automation, not 100% automation with at least some sort of approval chain and audit logs will prevent that from taking place. Okay? All right. Workflow systems to submit requests for new, changed, or terminated system access automatically get routed to the appropriate people for approval. That's what I was basically referring to in the last section. That's going to reduce bottlenecks. It's going to ensure accountability. For example, let's say a new hire request comes in. It's going to flow from HR, being the organization responsible for onboarding. It's going to go over to IT. It might go over to information security. But all of that together is going to trigger account creation in Active Directory, possible email provisioning, application access. You have tools like ServiceNow, SailPoint, Okta Workflows that can automate that chain, if you will. Okay? We can also trigger the creation of accounts and allocation of other resources. Once things get approved, the workflow initiates that account creation, and then it assigns all of the resources like email, like file access, file share access, application access. This is where our policy meets automation. Role-based templates can define what access say, a new person being hired as a financial analyst might get. So we're minimizing the need for manual provisioning. We're enforcing least privileges right from the very beginning. Okay? Last bullet point here. Well, not quite the last bullet point. Automatic replication of data. Third bullet point, I should say. Particularly user records between multiple systems and directories, right? What does that mean? That means that user data should be automatically synchronized across systems and directories to maintain consistent access permissions, right? Directory sync, Azure AD, Okta Universal Directory. These are going to make sure that changes in one system, like updating a name, department change, whatever, that's going to propagate to what? That's going to propagate everywhere. So we're not going to have mismatches that could lead to access denial. We're not going to have over provisioning and so on. Assuming we have timely and universal propagation of those access changes, we're not going to have discrepancies. It's going to minimize the risk of misconfigured permissions. For example, if a user gets promoted, their new access rights should be reflected across their email, file systems. If they have access to cloud application, it should pretty much happen immediately. All right. Otherwise, if there are delays, you could have security gaps, especially if you're reducing the level of access. But you can have operational inefficiencies as well. All right. Facility for loading batch changes to user directories. What does that mean? Systems should support the ability to do bulk updates to user directories so that we can streamline large-scale changes, which then will also help to improve accuracy. Whether you're onboarding a new department, revoking access for a terminated team, these batch operations could be done through PowerShell, API calls, right? If you're integrating different disparate applications, CSV imports, comma separated variable imports. This is going to save time. It's going to reduce manual errors, especially if you're doing through like seasonal employee rotational changes, or you're going through a merger or acquisition or whatever. Access provisioning and deprovisioning should be policy driven, meaning that we automatically trigger these policies by changes in directories, employee records, whatever it might be, right? This is actually kind of at the core of identity governance. If HR marks an employee as terminated, their access should be revoked across all systems immediately. If their role changes, access should be adjusted immediately according to that new role. Again, reducing the idea or the potential of insider risk, making sure that we have compliance with least privilege principles and so on. Okay? What are some of the challenges with account management? Challenges for security actors comes with decommissioning. Onboarding is one thing, right? If you're provisioning accounts, yeah, you want to make sure that they're provisioned to the same level, right? But at the same time, if somebody doesn't get provisioned in a timely manner, the exposure might be fairly minimal. All right? However, deprovisioning is different. So the most complex and risk-prone phase of account management is decommissioning users when they leave. Why? It's not really just about disabling their login. It's about making sure that every access point, privilege, any identity artifact that's tied to that user gets removed, right? So you could have dormant accounts left over. Guess what? Those dormant accounts are prime targets for exploitation. Having a centrally managed identity repository is essential for tracking, meaning that we're managing all user-related data during the offboarding process. Without a single source of truth, like an authoritative HR system or identity governance system in place, we can struggle to locate what remnants exist for accounts for those individuals that are tied to that user. Meaning that we're going to have a fragmented deprovisioning process, and that's going to lead to audit gaps. So having centralization gives us that full visibility, and it allows us to essentially coordinate the shutdown efforts. Decommissioning also absolutely has to include the removal of all group memberships and roles. Right? We need to be able to revoke the access across every system that the user had access to. A user might belong to different nested AD groups. They might have different cloud IAM roles. They might have specific app-related access lists. If even one of those roles stays active, could be a shared mailbox, could be a VPN-enabled account or whatever, there is risk. So we need to have that automated role. That's what we're talking about. If we don't have a unified system that gives us the ability to track user identities, security teams will not be able to confirm whether the decommissioning was completed appropriately and that it aligns with organizational policies. All right. There's no operational assurance. There's no audit readiness. For example, during some sort of compliance review, you might need to prove that terminated users had all their access revoked as part of an SLA. But if you have a fragmented identity landscape, it's going to kind of make it almost impossible. You also need to make sure that you have complete documentation. Incomplete, undocumented decommissioning, I should say, that's going to pretty much mean that your security teams are not going to be able to demonstrate compliance. And then we have regulations that mandate this as well. HIPAA, GDPR, SOX, Sarbanes-Oxley, they're going to require time-based verifiable access revocation. And if you don't do it correctly, guess what? Fines, data breaches, even reputational damage, right? And governance platforms themselves, they're going to include things like audit trails, policy enforcement, to be able to support these things. Okay? Profile management is a collection, or a profile itself is a collection of information associated to a particular identity or group. That could include personal information. It's a structured set of attributes that gets tied to that individual. It includes static data, right? Maybe your name, your department, whatever. But it also can include dynamic data. Like, what is your role? What are your access history? Right? But profiles are kind of foundational as well to identity management, identity governance, and to enable policy enforcement. It can also enable things like personalization. Of course, there's an auditability concept as well. Okay? So these user profiles, they do tend to include personally identifiable information, certainly contact information, maybe demographics, individual identifiers, so that data is considered sensitive. It could actually even be protected with regulations like GDPR, CCPA, HIPAA. We talked about those in previous domains. And it's often a source from HR systems to allow us to synchronize across different directories, across different applications. Profiles will also most likely include some sort of access entitlement. what systems, what data, what actions a user is authorized to see. So it could be a group membership, RBAC roles, policy tags. So as an example, a user could be, a profile could say, oh, they're a finance approver. What does that mean in SAP? That means that they have certain privileges, or they could be a read-only analyst, right? Those attributes are what drive enforcement. Also, kind of dictates our provisioning logic as well. As users change roles, they go into different departments, their responsibilities change. That profile data needs to be updated to reflect those changes. This is where lifecycle automation is absolutely critical. Like I said in the previous slide, a promotion should trigger updates to your access rights, to the reporting structure. There should be different compliance flags. Without these timely updates, users can actually maintain outdated privileges or excessive privileges. And of course, that's a direct violation of a least privilege principle. So again, I'm kind of repeating myself a little bit here, but profile changes automatically should propagate across all systems so that we have consistency. If a user's department changes in HR, that should update and reflect that information in the corporate directory in a time tracking system with their access control lists or whatever. You do have directory sync tools, and we're going to get into directory services here in a little bit, that help enforce this propagation. CRM platforms, customer resource management or customer relationship management platforms will include profile management features as well, meaning that you can use users or administrators, whatever, can update business-related data for customers. In Salesforce, you can update contact information, preferences, roles, etc., and that can trigger downstream changes in marketing support, access workflows, or whatever. All right, access and password management tools include things like profile management features so that we can personalize and update identity information. Okta, like I said, or Okta, I don't know, OKTA. I've always said Okta, but it could be Okta. Or Azure AD lets you update non-sensitive attributes, things like phone numbers, that kind of thing. Or you can even manage multi-factor authentication settings. We talked about that a couple slides ago, right? We were talking about reducing help desk load, giving users the ability to provide at least some level of governance. Okay. Systems should permit users to update their non-sensitive profile data, preferred name, phone number, right? That typically shouldn't require any kind of formal validation. This is going to allow us to balance usability with security. If you have sensitive changes, like social security number, legal name, etc., that might require administrative approval. But for low-risk updates, self-service or self-provisioning, I guess it would give the user a little bit of satisfaction, but it also provides for better scalability. Does that make sense? All right. Directory management, and we will be talking about different directory structures, X500, LDAP, and so on. But directory management gives us a comprehensive database, a centralized repository that allows us to organize and manage data about users, devices, possibly services, maybe more. All right. Think of this as kind of like the authoritative source for identity metadata to support things like authentication, authorization, I guess in terms of policy enforcement, and then accounting as well. Directories typically use a hierarchical structure to store those objects, users, groups, devices, resources. And that will kind of mirror your organizational structure. The OU is based on Active Directory or tree-based, like you see in Lightweight Directory Access Protocol, Authentication Protocol, excuse me, and enables an inheritance of policies and kind of simplifies delegation as well. Directory services provide an interface where users and systems can interact with the data that's stored in that directory. Microsoft Active Directory DS, domain services, Azure AD Graph API, those would be examples. So we can do our authentication, we can do lookups, we can do policy application. Applications themselves can actually get information from the directory using different protocols. LDAP, the Lightweight Directory Access Protocol. I think I said authentication last time, I apologize. Access Protocol, or its secure variation, LDAP-S. LDAP is kind of one of the most widely supported apps used for authentication. Group membership checks, attribute queries, that kind of thing. It's really kind of the backbone for SSO as well. And if you're doing federated identity in legacy systems. We'll learn more about it technically over the next couple of slides. Centralized directories eliminate redundant user data across applications. This is going to streamline identity management. It's going to reduce administrative overhead. So instead of each app maintaining its own user store, they can reference the directory. What's that going to do? That's going to provide consistent access control. It's going to provide for faster onboarding and offboarding. Excuse me. It's also going to provide for unified audit trails. Different applications can be integrated with the directory so we can share user data, which is going to enable consistent identity enforcement. Centralized security policies. I mean, that's really the heart of IAM, right? Integrating HR platforms, CRM platforms, cloud apps with Azure AD, role-based provisioning, conditional access enforcement. A big challenge in directory-based identity management, though, is the integration with legacy systems that maybe don't support the schemes, right? Older applications might not do LDAP. They might not do SCIM. So you would have to create custom connectors or have some sort of middleware application, which again introduces complexity, but it can also introduce security gaps. Or it could even introduce synchronization delays, right, when you're sharing information. All right. Now, let's get into some of the tech side, right? The technology. And LDAP and X500, these are definitely things that you're going to have to be familiar with. All right. One of the most common directory standards is X500, or LDAP, which is really based on the X500 architecture, Active Directory, X400, and so on. All right. X500 really kind of laid the groundwork for this hierarchical schema-driven directory. LDAP emerged or was born from it as a lightweight alternative to X500. Active Directory is actually built on LDAP, but it has specific Windows enhancements. X400 was used before for like email routing, stuff like that. You won't be tested on X400. It's not really something you're going to see. All right. X500 was created by the ITU-T, International Telecommunications Union, technology sector in the late 80s and early 90s to provide standardization for directory services across the network. It was part of the OSI initiative, meaning we want to create a global interoperable directory system. However, X500 was very complex. It was heavy, right? It did include a lot of concepts that we see in LDAP, which is X500 Lite. DNs, distinguished names, hierarchical object classes. We see that in LDAP. We'll do a deeper dive into that over the next couple of slides. All right. Now, formally recognized, 9594-1, you're probably not going to need to know that for the test. Updates happened in 2008 and 2014. We see those updates to kind of reflect different definitions, protocol refinements, not really implemented in full today, but it still influences what a lot of modern directory services designs and compliance frameworks use. All right. Enterprises basically needed a way to unify identity data across different systems. Okay? Mainframes, Unix systems, Windows systems, and this X500 scheme provided a common language. All right? The problem with X500 on its face, though, it wasn't really very practical. It was designed to operate within the OSI model, the Open Systems Interconnect model, to support a distributed directory access platform across different networks. It mapped actually very neatly into the OSI layers using protocols like Directory Access Protocol, which is the primary protocol used in X500 directory. It made it kind of theoretically, if you will, elegant in terms of its operation, but it was very heavy. And that's why LDAP became kind of the preferred alternative, because it runs over TCP/IP, right? So you don't need to know DAP, DSP, DISP, DOP. Their acronyms are there, but those are the four separate protocols that kind of make up X.500. Why does it still matter? All right, X500 really isn't widely developed today, but its DNA, its foundation runs through LDAP, runs through Active Directory, and even gets into cloud-based IAM solutions. Hierarchical naming, schema enforcement, distributed replication exist in all those platforms. All right. Information in an X500 directory is organized as a hierarchical database. That's what I was just literally saying in the last section, right? Key fields in the database are called distinguished names. The hierarchy itself kind of mirrors things like OUs, organizational units, departments, geographic regions. It enables things like the inheritance of policies. It will simplify delegations. So think of like DC, which is domain component, would be company. OU, which is an organizational unit, would be maybe finance. And common name, CN, might be Scott, as an example. All right? But that distinguished name uniquely identifies an entry by specifying the full path within the directory hierarchy. Think of it like a full path in a file system. CN equals Scott, common name equals Scott, OU equals security, DC equals thinKtank, and DC equals com, right? So thinKtank.com or whatever. That directory, or distinguished name, I should say, tells you exactly where the entry lives in the directory tree. Think of it as a locator, defining the exact position of an entry within the structure of the directory. Very critical for search operations or even access control or replication as well. Applications will use those DNs to bind to specific entries and then apply policies to retrieve attributes and so on. Okay? The RDN, which is the relative distinguished name, identifies entries relative to its parent. We don't have the full directory path. If the DN is like the full address, the RDN is like a local name. So for example, in the DN that I mentioned before, Scott, thinKtank.com, whatever, CN, the common name Scott, is the RDN. That's useful for binding queries, navigating through subtrees, and so on. The RDN is just a single attribute value pair that identifies an entry within the context. So it's used in filters, or if we're constructing DNs dynamically. If I want to provision a new user, I might start with CN equals new user, common name equals new user, and then I append that to the OU. All right? Now, X500, very, very robust protocol, but notoriously difficult to deploy and manage. It's very complex. Full X500 implementations, you have to have the full OSI stack integration. There has to be very, very strict schema adherence. It's a very heavyweight protocol. And that's why LDAP came out. Okay? OSI model is elegant, but it's impractical when you compare it to TCP/IP. So just think of LDAP as kind of a streamlined version of DAP. We're getting rid of the full stack requirement. We have broader adaptation, Unix, Windows, cloud platforms, and so on. All right, X500 deployments, you probably won't see them. But the concepts that were built into that, DN, RDNs, hierarchical schemas, they still exist in LDAP, Active Directory. So understanding where we came from kind of understands how we can design, or provides us the ability to understand how to design scalable identity trees, interpret access control logic, and so on. So let's do a deeper dive into LDAP. LDAP came out early 90s. It's a lightweight alternative to X500, as we talked about before, the directory access protocol, but kept its structure, right? Okay. LDAP is basically ideal for internet scale identity, and actually kind of was the precursor to things like Active Directory, Open LDAP, even cloud directory integrations. LDAP really simplifies the directory services deployment because it uses a streamlined protocol. It's a flexible schema, not rigid like X500. All right, LDAP simplifies the deployment. It's much easier to integrate with modern applications. There's a secure component to it as well in terms of LDAP-S, very efficient queries, and really the backbone of most identity and access management solutions. It uses a tree-like hierarchy. This tree structure is what is used to reflect the organization structure, but also the functional relationships. Why is that important? That's going to allow us to delegate responsibilities and roles. It's going to allow us to do policy inheritance. It's going to provide for logical groupings, DC company, OU engineering, common name Scott. And that mirrors the domain and the department. Every LDAP entry, like I said, is identified by a unique DN, and that includes at least one, but probably more than one RDNs that represent its position in the tree. The DN, like I said in the previous slide, it's the full path. The RDN is a local identifier. Very, very crucial if you're talking about building search filters, providing access control, doing replication logic, and so on. These entries consist of name-value pairs. All right? They're made up of attribute-value pairs that define identity characteristics. Common name equals Scott. Mail equals Scott at thinKtanklearning.com. User ID or UID equals whatever number. Member of could be like admins or groups or domain. That's what drives AAA, authentication, authorization, accounting, and the principle of least privilege and personalization. All right? All right. LDAP operates on a client-server architecture. Clients are going to make requests for access to the LDAP server, and the server is going to respond with results. Okay? This separation allows centralized identity management. Clients can be applications, they can be authentication services, they could be command line tools like LDAP search, but the servers are typically the directory services, Active Directory DS, we'll talk about that in a couple of slides. Clients then can query these LDAP servers to get the identity related information. That server is going to respond with the related data based on the request type. It's going to respond with the permissions. Those requests can include a bind action. Bind action would be like authentication, meaning we're authenticating to the server so we can do our search. Attribute lookups, group membership checks, and then the server can then enforce access control lists to identify what data the client can see, what data they can modify. Okay? So there are a lot of different operations. Bind means that we're authenticating to the directory. A search means that we're querying entries in the database, but by using filters. Compare would be another action, right? Checking if attributes match a particular value. Adding, deleting, modifying, which means we're managing the entries in the database. These operations are atomic. They're schema aware. Modifying a user's mail attribute has to conform to the directory schema rules. LDAP by default operates over TCP port 389 if you're not using encryption. That's okay, I guess, if it's internal and it's on a trusted network. But obviously, if you're over a public domain, you want to make sure that queries and credentials and whatnot are not being sent in plain text. LDAP version 3 does TLS. LDAP-S. That's going to allow us to encrypt data in transit. That's going to enhance and provide for confidentiality, integrity, etc. It runs over TCP port 636. All right. Start TLS started over port 389. TLS is kind of essential for a lot of compliance domains, HIPAA, PCI DSS. We need to be able to protect credentials. We need to be able to protect sensitive attributes. All right. By the way, LDAP also often gets tied into authentication workflows. SSO. We're feeding identity data into an SSO environment. SAML, OIDC tokens, access control based on group membership of retrieved attributes, member of or user ID. That's going to drive things like RBAC decisions in applications. And then we have hybrid sync. LDAP directories can sync with IAM platforms, with SCIM, or different connectors. Guess what that does? That ensures consistent identity across domains. Okay? Active Directory Domain Services. Think of ADDS as Microsoft's version of LDAP, but it's specifically tailored towards a Windows environment. In a Windows environment, it's kind of the backbone for identity management to do authentication, authorization in just about every Windows domain. It does have cross-platform LDAP compatibility as well. ADDS can actually integrate with other systems like Unix or Linux or mainframes. You might have to use some sort of plugin, or you might have to use federated tools, but this can make central identity provider functions, even in a hybrid or multi-platform setup, a lot easier to manage. Okay? It also supports centralized authentication and authorization. ADDS acts as a gatekeeper. It verifies who you are, which is the authentication piece, and what you're allowed to do, which is the authorization piece. It also supports Kerberos and NTLM, and it's tied into group policy to do what? To give us granular control. All right? So it definitely gives us policy enforcement at scale through group policy objects. ADDS can actually push security configurations across, hundreds or even thousands of computers. That could include things like password policies, software restrictions, even desktop settings. It also provides for uniform and auditable security controls. ADDS logs all of the authentication events, any policy changes, access attempts, which is going to be absolutely critical for what? If we're trying to identify audit trails, if we're doing any kind of forensic analysis. It does support RBAC. It can be extended with tools like Microsoft Defender for identity. It has hierarchical naming structures like LDAP. It actually uses a tree-like structure. We have domains, we have organizational units, and then we have objects. Those objects could be users, they could be computers, they can be groups. That hierarchy is going to support the delegation of administrative control, but more importantly, it's going to provide for scalable management. All right, imagine you have an enterprise with an on-premises ADDS and you're running Azure AD. ADDS obviously would handle the legacy systems and all of your internal applications. Azure AD would extend that identity and access management to your cloud for things like Microsoft Office 365 or just 365. It'll provide for conditional access constraints, multi-factor authentication, and these tools will also allow us to synchronize identities, which provides the ability to do single sign-on across different environments as well. Okay? All right. ADDS forest and trees. ADDS directories are organized into forests and trees. Forests are a collection of all objects and their associated attributes. Trees are logical groupings of one or more ADDS security domains within the forest. Think of a forest as the trust boundary. That's your top level container in ADDS. And like I said, it includes all users, groups, computers, all the attributes, the schema, the configuration, and more importantly, your global catalog. It is what we use to define our security boundary. In other words, forests don't inherently trust each other. If you want one forest to trust another forest, you have to configure that trust explicitly. So the trees themselves, these are my DNS-based hierarchies. A tree is just a grouping or a collection of domains that share a contiguous DNS namespace. So for example, corp.thinKtanklearning.com or sales.corp.thinKtanklearning.com. Those are technically part of the same tree. Trees within the forest automatically trust each other. That's called a transitive trust. Domains is where we apply our security and policy units. Basically the primary units for things like authentication, authorization, policy enforcement. Every domain has its own domain controllers. These can have unique group policies. Domains get named using DNS, sales.thinKtanklearning.com as an example. And then we have organizational units, OUs. This is where we do delegation and grouping. OUs are basically containers within the domain to group objects logically, by department, by function, whatever it might be. This is going to allow for the delegation of administrative control without having to create new domains. So GPOs can be applied at the OU level. And we would typically do that, by the way, if we're trying to manage granular policy targeting. So let's say you're designing an ADDS for a multinational enterprise. We would create a single forest to maintain the schema for that enterprise and the trust boundary. And then each region, like USA.thinKtanklearning.com, Asia.thinKtanklearning.com, those become a domain within the tree. And then each domain, we have OUs like finance or IT or HR, and that will allow us to delegate local control to those domains, and group policies get scoped to the OU. And that allows us to enforce, in this example, region-specific security settings. It still balances the idea that we have security control centrally managed, but we have some local flexibility. Okay? All right. Another concept when it comes to AAA is this idea of single sign-on. It's basically a generic term. We use it to describe a unified login experience from the perspective of the end user, of course. So single sign-on allows users to authenticate once, and then they're going to get access to multiple systems. They're not going to have to re-enter their credentials each time. So from the user's perspective, it's kind of seamless, right? You get one login, but you get access to a lot of different resources. All right. Reduced sign-on or federated identity. There's a difference here. Reduced sign-on typically means that credentials are reused across systems within a single domain or within a single trust boundary. Federated identity extends the single sign-on concept across different organizations or even different platforms. So logging into Salesforce with your Azure AD credentials. Okay? Master system authentication is where we're authenticating to a central identity provider called the IDP. Could be ADDS, could be Azure AD, could be Ping Identity, Okta, whatever. Once you're verified, tokens or assertions, and we'll talk a little bit about SAML a little bit later on. OAuth and SAML are examples of tokens. OAuth would be a token-based algorithm, and SAML would be more related to assertions. They get passed to other systems, which ultimately results in granting access to that individual. Okay? SSO relies on a centralized directory, ADDS, LDAP, whatever it might be. That directory is going to store and validate credentials. This is going to simplify user provisioning, deprovisioning, auditing, and so on. So imagine a user logs into their corporate laptop. They log into ADDS, Kerberos tickets get granted access to Outlook, to SharePoint, to Salesforce. That happens behind the scenes because SSO tokens get exchanged. Azure ADFS, Active Directory, and Azure AD, they're going to act as the federated bridge for your cloud applications. Basically, the user doesn't have to retype their credentials. Very common in like a hybrid enterprise, well, in most enterprises actually, even if they're not hybrid. All right, what are some of the single sign-on advantages? Obviously, a much more efficient login process. You have to remember fewer passwords and less interruptions when you're doing your job. Right? Basically, a seamless user experience. Better productivity, right? Users only need to remember one strong credential. That's also going to reduce password fatigue and probably even reduce friction across different systems. We also have credential consolidation. SSO introduces what we call a master credential, and that's what's going to unlock access to multiple systems. The backend system may retain unique passwords, but users only interact with the SSO interface. This is going to mean that we're going to have stronger password hygiene. If I have fewer passwords to manage, I'm more likely to create complex, memorable passphrases. That's going to remove my reliance on insecure practices. Like what? Password reuse, sticky notes, that kind of thing. We also have enterprise-wide policy enforcement, access control standards like session timeouts, password complexity, multi-factor authentication. These are now uniformly applied across all of my applications. This means that we have consistency. It simplifies compliance with frameworks like ISO 27001 that we talked about in a previous domain, PCI DSS, NIST guidelines, and so on. We also get a single pane of glass to manage identities, to manage access rights, and to look at auditing, or audit logs, I should say, really. This is going to simplify the onboarding process, offboarding process, different role changes, different incident response. Okay? What are some of the concerns? I would say probably the most relevant concern would be if for some reason authentication is compromised, now this individual is going to have access to everything. That master SSO password is like the crown jewels. If for some reason it gets compromised, guess what? I get access to all the systems that are now linked with that process. So attackers will often target SSO credentials because, quite frankly, the end result is pretty critical. It's kind of a low-hanging fruit, right? There's also credential aggregation risk. A lot of SSO systems store credentials and authentication metadata in a central database. So if that database gets compromised, that blast radius then can kind of go across the entire enterprise. You have to have a hardened infrastructure. SSO systems have to be fortified or secured with multiple layers of defense, multi-factor authentication, encryption at rest, encryption in transit, role-based access control to the admin interface, regular vulnerability scanning, patching, that kind of thing. All right? Also, monitoring, detection, these are non-negotiables. You have to have real-time logging. You have to look for anomalous behavior. You have to have alerting. So we're going to integrate SSO platforms with SIEMs, right? Security incident and event management platforms like Splunk or Sentinel. That's going to help us correlate suspicious activity across different systems. And I guess another downside, the last bullet point, could be complex. Enterprise grade SSOs, they're not really plug and play. You need directory synchronization, like getting from ADDS to Azure AD. You need federated protocols like SAML or OAuth or OpenID Connect. You have to have trust relationships that are built across domains and different platforms. There has to be very, very careful onboarding and offboarding workflows as well. Make sense? All right. What about script-based single sign-on? If you don't have an integrated SSO, or you have a lot of customized application in use within your organization, you can implement your own solution with custom scripts. So we're saying basically the off-the-shelf solution doesn't integrate well. We have customized applications, we might have some legacy systems, so we might build our own SSO using scripts, and those scripts basically simulate user behavior. So it's going to inject credentials into login forms or APIs. The scripts drive your authentication workflow. They act as proxies. They handle the login prompts, they pass credentials, they manage tokens. These can also be deployed with local agents, or you can incorporate them into browser extensions, but more specifically, they can be tailored to specific needs. We can fine-tune the behavior if we have individual workflows that are kind of unique, legacy systems, proprietary platforms. Very, very appealing in environments where you have either tech sprawl, right? You have a lot of diversity in technology, or you have outdated technological stacks that just simply don't support integrated off-the-shelf SSO. Custom SSO scripts do require ongoing maintenance, so there is a little bit of high cost and complexity. App user interfaces, if you upgrade them or you patch them or update them, they can break those scripts. Credential storage, encryption has to be handled securely, but I don't know, it kind of has to be done anyway, right? In any type of SSO environment. And there are security implications as well. Scripts might actually store credentials locally, or if it's not written correctly, those scripts can transmit insecurely. So they could bypass traditional authentication protocols. This is going to increase your attack surface as well. You have to make sure you vet the solution. Look at things like code reviews, look at secure storage, look at audit logging, and so on. All right. Now, we've had this discussion a few times in previous classes. This is kind of an in-depth discussion of Kerberos, although I'm not sure that you'll need to know this much detail for the exam, but we'll break it down. Okay? All right. So what is the Kerberos Authentication Protocol? It is a ticket-based authentication mechanism that we use over an untrusted network. So Kerberos basically uses tickets to prove identity across the network. Those tickets actually have a timestamp. They can be encrypted. Well, they typically would be encrypted so that we don't have any exposure to things like replay attacks. All right. It's named after Cerberus, the three-headed dog guarding Hades. The triad of client, server, and key is kind of how it was developed in this case. Not that that's a test question, but kind of interesting. All right. So in this case, we're talking about the client being one piece, the server being another piece, and the KDC being the third piece. That's the key distribution center. All right, layered protection, basically, mutual verification and validation. All right, it is a mutual authentication built into a client-server model. That means that both the user and the service validate each other's identity, which is kind of beyond what we would typically see with basic logins. So there cannot be any opportunity for man-in-the-middle attacks, impersonation, and so on. Now, what are the cryptographic foundations? We use symmetric key cryptography or shared secrets. That's primarily. Optionally, we can integrate public key cryptography if we're doing some sort of pre-authentication or if we're running some sort of smart card scenario. But all of the messages in the protocol are encrypted, meaning we're providing confidentiality. The trusted third party in this case is the KDC, the Key Distribution Center. We'll see it over the next couple of slides, but the KDC issues something called a TGT, a ticket granting ticket, and an ST, a service ticket. All right, this is really the heart of Kerberos. Now, there are default ports, as you see on the page here. Kerberos runs over UDP port 88. All right, developed by MIT for Project Athena, designed to secure a distributed computing environment. Okay, so let's say I'm in a Windows enterprise. A user logs in. ADDS is going to use Kerberos to issue the TGT. That TGT is then used to request a service ticket for applications like file shares, printers, SQL servers. The user never retypes credentials. It's all handled with this encrypted ticket exchange. This kind of goes back to what we were previously talking about, the underpinnings of Windows SSO and smart card integration and multi-factor authentication. All right, so I kind of alluded to a little bit of this in the previous slide. The client authenticates to an authentication server, which forwards a username to the key distribution center. So that's the initial authentication to the authentication server. The username goes to the AS, which is part of the KDC. The AS then verifies the user and issues the TGT, the ticket granting ticket, which is encrypted using the ticket granting service's secret key. I have a diagram that shows this a little bit later on, but even though we're going to discuss this, I probably wouldn't put too much emphasis on knowing the specific ins and outs of Kerberos. Understand its general purpose and the general architecture, but you don't need to really know what key encrypts what message and the exchange of information. We'll still go through it, but you don't need to know it specifically. Okay? This ticket granting ticket gets sent to the client, and then that's going to get stored on the client for session usage. Okay? These ticket granting tickets, they're usually issued when you log in, and then they will expire after a specific amount of time. Could be 8 hours, could be 16 hours, whatever. And then the renewal, if they're expired, those get handled transparently by a session manager if the policy allows it. Now I've got my ticket granting ticket, I need to request access to a service. So if I want to get to a file server, I send the ticket granting ticket to the TGS. Very important, this request includes the SPN, the service principal name. That's a unique identifier in Kerberos that allows us to uniquely identify the target service that we're trying to access. The TGS then issues a service ticket. All right, sorry about that. The TGS then issues a service ticket. It's not going to do that until it validates the TGT and the SPN, but it's going to issue a service ticket and a session key. Those get encrypted and then they get sent to the client. The last major step is accessing the service server. So the client presents this service ticket to the service server with its unique request, whatever that request might be. The service server decrypts that ticket, verifies the session key, grants access if everything is good to go. Does that make sense? Okay, so here's a diagram that kind of visualizes this process. And again, you probably look like that guy there on the right side of the screen, but you don't need to know this for the exam. But let's break it down, right? A to B. That's the initial authentication request. The client sends its username to the authentication server. Like I said, the authentication server checks the identity, forwards it to the KDC, which is the key distribution server. B, the ticket granting ticket gets issued. The KDC returns the ticket granting ticket, which is encrypted with the ticket granting service's secret key. Okay. The ticket gets stored on the client, and then that's used for the service request. D is where we're doing the request to access a service. The client sends the ticket granting ticket and an authenticator, which in this case is just a time-stamped proof of identity, to the ticket granting server. This proves that the client is still valid and it's requesting access to the SPN, the specific service. F, the ticket granting server issues the service ticket. So we validate the ticket granting ticket, we validate the authenticator, it returns the service ticket and the session key to the client, which is encrypted for the target service, not the client, but the target service. Then we move over to G, which is the client then sends a message to the service server. It sends the service ticket and a new authenticator to the service server. This proves the client's identity and the client's desire to access that specific service. Finally, H, the server responds with a timestamp. The SS server, service server, it's going to decrypt the ticket. It's going to validate the session key, and then it's going to respond with a timestamp. Now we've done our mutual authentication. Both sides trust each other, and we don't look like this anymore. Okay? All right. The user enters a username and a password on the client machine. All right. What does that mean? Well, basically, we're just trying to access information, right? You could have PKINT. That stands for Public Key Cryptography for the initial authentication. In Kerberos, that's actually defined by RFC 4556. That could be used instead. So we're replacing basically passwords with asymmetric keys. That would be better for security, I suppose. But we can also do password to symmetric key transformation. The client actually in this case doesn't send the password across the wire. Instead, it transforms that password into a symmetric key. That key is what is used to decrypt the ticket granting ticket received by the authentication server. Excuse me, received from the authentication server, not by. Okay? Now, it does depend on the cipher suite you're using. Some built-in key scheduling algorithm, or some algorithms use built-in key scheduling like DES or RC4. Others will use like a one-way hash function like SHA or variations of SHA. Why does it really matter, right? The password never leaves the client. Only derived keys get used, so we're minimizing the exposure of passwords. It also provides for replay protection because all of the authenticators include timestamps. So even if they're intercepted, they will expire in a short amount of time. Okay? All right. The client sends a clear text message of the user ID. You know what? I don't really need to go through this because we've already discussed this. This is the breakdown of the diagram that we saw previously. I didn't realize that until just now. I've already broken all this down, right? So you can use this for notes if you want to pause the video and take a look at it, but we've already covered this information. Okay? Message C, message D, we talked about that. Message E, message F, we talked about that as well. Same thing here. All right, we also talked about how the service server, it's a little bit more detailed here than probably what I was describing, but again, you don't need to know these details for the exam. It's mainly for your information. You've seen that throughout the class. I've included a lot more detail in a lot of the slides because I want you guys to have information that's useful, right? But again, we've covered this, so we're going to move on past this particular slide. Okay? So that concludes our discussion of Kerberos. Perimeter-based web portal access. If an organization has a directory like LDAP, it is possible to leverage LDAP data to manage identity, authentication, and authorization on web applications that use a web portal with web access management. We're talking about like centralized web authentication. LDAP is the identity backbone in this case. If we use LDAP, we can leverage that to manage anything. Now, there is a term we use called web access management. Basically, this is a solution that sits on the perimeter, typically deployed like a reverse proxy or some sort of CWA portal, but it's a plug-in architecture for single sign-on. We use plugins or agents on the web server to intercept the login requests, and instead of each app handling its own login, the portal authenticates the user one time and then passes that identity assertion downstream. So we have session management across applications. Once we're authenticated, that portal is now going to maintain the user's session state. So as we navigate between applications, the portal itself is the one that's going to be injecting credentials or probably tokens, which enables this SSO functionality. So we have group-based access control. So WAM actually will integrate with LDAP, and that will allow us to enforce role-based access. We can define policies. So like, for example, the finance group can access the payroll portal, or contractors are restricted from accessing internal HR tools. This is really effective for web-based SSO, but it doesn't typically extend to legacy systems. And it's definitely not going to give you full enterprise access control. It's individually scoped to web-based environments. Okay? Now, what about SAML? You're definitely going to have to know about SAML for the exam, the Secure Assertion Markup Language. All right. So, what is it? SAML is an open standard developed by Oasis for securely exchanging authentication and authorization data between separate security domains. Usually it's going to be between an IDP, which is an identity provider, and an SP, which is a service provider. SAML uses XML-based tokens. Those tokens are called assertions, and those assertions convey identity and access rights. Those assertions get passed from the identity provider to the service provider after the user, which is also called the principal, authenticates. So there are key roles, right? The principal is the end user that's trying to access a service. The identity provider authenticates the users and issues assertions, and then the service provider consumes that assertion and then ultimately grants access. So for the flow authentication, the user is going to try to access a service, which is SP. SP then redirects to the IDP for authentication. IDP authenticates the user and sends a SAML assertion back to the SP. SP then uses that assertion to make an access control decision. Am I going to allow the user to access the service or am I not? So SAML's really, we use it every day, right? It's really used a lot in cloud applications, enterprise applications, and so on. You've probably seen it multiple times in your career. All right. Now, before delivering an identity assertion to the SP, the IDP may request additional information from the principal. All right. So it could prompt for additional credentials, username and password. Most likely, it's probably going to be some sort of MFA. Why? We want to make sure that the assertion is based on verified identity. These assertions are trust messages. SAML defines these structured assertions, which are XML messages that declare facts about a user, its identity, group, membership, session validity, that kind of thing. These get passed from the IDP to the service provider. Why? We're trying to support decisions on providing access. All right? It also provides many-to-many trust relationships. A single IDP can be used to issue assertions to multiple service providers. This provides centralized identity across many different services. A service provider also can trust multiple IDPs. So if we're doing like B2B ecosystems or higher education, we can have federated environments, and this is really helpful for that, right? All right. What are some of the standards that we use with SAML? XML is foundational. The extensible markup language. This is how messages are exchanged, or expressed, I should say. It is essentially the whole SAML architecture is built on XML. XML is just a structured, machine-readable data format which allows us to encode identity assertions and different protocol messages. We use the XML schema for the structure. So SAML assertions, protocols get defined using an XML schema. This means that we have consistency and validation across different implementations. We also have an XML signature. The XML signature is going to be used for things like integrity and authentication. This started in SAML 1.1, but it's also used in 2.0. We use XML signatures to digitally sign the assertions. What does that mean? That means that the messages are not going to be tampered with. That means that they came from a trusted IDP. And then we have XML encryption. To do what? To support confidentiality. So we protect things like identifiers, assertions, attributes. SAML 1.1 didn't really have encryption built in. That's why most people use a 2.0 deployment for that reason. HTTP is the transport layer. I know HTTP is an application, but typically we exchange SAML messages by using HTTP. We use redirects or we use post bindings, and that will carry those assertions from the IDP and the service provider. And then we use SOAP for advanced messaging, right? If we're doing complex integrations, asynchronous interactions, artifact resolution, any kind of back channel communication, that's going to be done with SOAP. All right? All right. Two Federation partners can choose to share whatever identity attributes in SAML assertion messages, which is assertion payload, which are the messages, as long as the attributes are represented in XML. All right? That means that identity can be federated across domains, even if each party uses different internal standards. And we have a lot of flexible assertion formats. The XML structure supports lots of different formats, different attribute types, makes it a lot more adaptable to different identity systems and different policies. Okay? Enterprise federation is a very, very common use case. Enterprises will use SAML to connect to identity management systems like Azure AD, ADFS, and then we'll connect those to web applications like Salesforce or ServiceNow. This is going to enable centralized authentication, but distributed authorization. So we define something called the first mile and the last mile. The first mile is where authentication happens. That's the IDP. The last mile is where service provider and the web app sits. That's where we grant access based on the assertion. Okay? So if we look at the flow, SP sends an authentication request via HTTP, which gets redirected to Azure AD. Azure AD then authenticates the user and responds with an HTTP post with the SAML assertion. The service provider then consumes that assertion and either denies or grants access. Does that make sense? You need to know that concept. Now, do you need to know this specific workflow, the specific steps? Probably not. All right? Now, we're getting into something that you're probably a little bit more familiar with. 3 categories of authentication factors: something you know, something you have, something you are. Right? Maybe something you know is a shared secret known only to the user. Maybe something you have is a physical or digital object in your possession. Or maybe something you are would be like biological traits that are unique to you as a user. Now, what is single factor authentication? Uses just one factor. And in most cases, that's just a password. But this is going to be vulnerable to phishing attacks, brute force attacks, credential stuffing, all kinds of things. Multi-factor authentication means that we're making the use of 2 or more factors, but from different categories. So something you know versus something you have. This gives us much stronger assurance that the user is actually legitimate. Using 2 passwords or using 2 biometric options, this is not considered MFA because they're the same factor. All right? The more factors used to determine the identity, the greater trust of authenticity. So we use a combination of factor any combination of two factors is considered multi-factor. Although most secure systems require the use of all three factors, maybe. It's not that common because it's difficult to manage. Okay, so what is a token and how does that relate, right? Tokens are used by the claimant, the client, to provide identity, right? Basically, it's a device or it's software that's used by the user to prove their identity and authenticate to a system. It actually contains a secret that confirms that the user controls the token, which could be a time-based code or TOTP, time-based one-time password, or it could be a cryptographic key. Now, this could be software-based or hardware-based. Authenticator apps, browser tokens, very easy to deploy, very usable in a mobile type of environment. Or we can have hard-based tokens like smart cards, USB keys, one-time password devices. They're physically secure, and they're harder to compromise because you have to have the physical possession. What are the cryptographic models? Well, we have asymmetric. Remember, we talked about this in domain number 3. We talked about cryptography, private and public key pairs. The token stores the private key. Authentication involves proving the possession by signing a challenge with that private key. So the system that's authenticating you is going to say, hash this message and encrypt it and send it back to me. That's the challenge piece. You get the message, you hash it using a hashing algorithm that you both agree on, and then you encrypt that hash with your private key. Now when you send that back, I decrypt that with your public key and to verify that the hash is the same. Now I've verified your identity, authenticity, non-repudiation, etc. Conversely, we could use a symmetric key, which is a shared secret, a common key between the client and the server, right? This is typically used in a challenge response or direct comparison type of scenario. TOTP, for example, temporary one-time passwords or temporal one-time passwords. Tokens can also use things like challenge strings or nonces. A nonce, N-O-N-C-E, is a number that's used once to prevent any replay attacks. Some tokens can generate input internally, like a clock. And then we have activation requirements. Tokens could require activation data, like a PIN code or something to activate the token. We're just adding multiple layers of security. Here's some pretty pictures of different, although it's a little outdated, right? Who uses a BlackBerry anymore, right? But okay. Token-based authentication, physical or software token. Classic example of something you have, which could be paired with something like a PIN or password. Hardware, RSA Secure ID, YubiKey, smart cards, software, authenticator apps, mobile token apps, one-time passwords, OTPs. These are passwords that are generated one time. They typically will expire within a short period, 30 to 60 seconds. And once they're used, they become invalid. Hence the term one-time password. Some tokens do require activation data, like I said. Tokens can be a standard device or standalone device. They can be a USB attached device. They can be embedded into mobile applications. All right. So we use a synchronized token authentication model. All right. The synchronized token model means that the token and the authentication server are time synced. Every 67 or whatever the defined interval might be, that token generates a new value based on its own internal clock but the server uses the same algorithm and same time reference to validate the token's output. So we have initialization and validation. When it's first used, the token gets registered with the server that links to a specific user. During the authentication process, the server checks that the token is valid and active, that the user is in possession of the token by entering the number, and then we have an OTP or one-time password and a PIN, which then provides for multi-factor authentication. So the user typically enters a PIN, something they know, and then the token value, which is something you have, and that combination forms the one-time password. But it's only going to be valid for a short window, and it's never going to be used again. Tokens aren't actually just for digital systems. They can also be used for physical authentication, like unlocking a door or accessing a data center. RSA's Secure ID tokens, which is now under Dell EMC, classic example of the synchronized OTP devices. They come in a lot of different factors. I'm sure you guys have seen them. Most people nowadays will probably use, just for ease of management, they'll probably just use software-based tokens as opposed to hardware-based tokens. All right, what about biometrics? I mean, certainly we know from discussions in previous domains, right? Biometrics are based on something you are. It's a measurable, distinctive trait which is tied to human characteristics. What do we use them for? We use them to identify or verify individuals based on who they are, not what they know and not what they have. For authentication, we get realistic authentication, meaning it's very difficult to fake, to steal, or to forget that information, right? Because it's part of you. You can forget a password, you can forget to bring your card, but if you're there, you're most likely present, you can't be forgotten, right? We use this for things like access control, digital access control, physical access control. Two categories of biometrics: physiological, which is based on physical traits, fingerprints, palm vein, facial recognition, DNA. I have yet to see a DNA one in use, but iris, retina scans, hand geometry scanners, those kind of things. And then we have behavioral, right? Typing rhythm, gait, which is kind of how you walk or how you run, voice recognition, signature dynamics. Okay? Why are these so popular? Because they are unique to a person. That makes them more reliable than token-based methods, which would be like a smart card or a key fob, or knowledge-based methods like a password or a PIN. Now, can't remember if we got to this point the last time, but I think we got to this point, but we'll talk about it again. Biometric performance. Performance for metrics for biometric systems are based on different values. FMR, false match rate. FAR, false acceptance rate. Okay? This is going to measure how often the system incorrectly accepts an unauthorized user. For example, someone else's fingerprint gets mistaken to be your fingerprint. The lower the FMR, the higher the security. But this could also introduce user friction. We'll talk about that in a little bit more detail later on. False non-match rate, FNMR, false reject rate. This is going to measure how often the system fails to recognize a legitimate user. Now, that's a little bit more annoying, but the most dangerous element is FAR, false accept rate, meaning that you're actually incorrectly matching inputs to an individual. That's much worse than false non-match rates or false reject rates. So you scan your face, but the system doesn't recognize you. What happens if we have a lower FNMR? That means better usability. But it could also reduce security. We also have ROC, Receiver Operating Characteristics. This is a graphical tool that shows the trade-off between the FMR and the FNMR. We can adjust the threshold of the matching algorithm to affect both rates. For example, lower the threshold, fewer false rejections, more false exceptions. Now, this would be probably the worst scenario, right? If you set a higher threshold, that means fewer false accepts, but possibly more false rejections. I would much rather have false rejections than false exceptions, definitely. EER stands for the equal error rate. CER stands for crossover error rate. This is the point where the FMR equals the FNMR. What does that mean? We have a balance between security and usability. The lower EER means that the biometric system is more accurate overall. It's really useful when we're comparing different biometric devices or different algorithms. A lot of vendors will actually publish this information with their devices. So let's say your organization is evaluating a fingerprint scanner for secure access to the facility. If it's a security focused site, they're going to prioritize a low FMR even if the false reject rate is higher. If it's a high traffic office, they might prioritize a low FRR because they don't want to have user frustration. The ROC curves are used to visualize the trade-off and select the device with the lowest EER, equal error rate. Make sense? Okay. Now some other terms, and by the way, you probably will have to know these terms for the exam. Okay, this is the kind of thing, not by definition, right? They're not going to ask you on the exam what an acronym means. They're going to give you a scenario, and you're going to have to identify how that's represented based on your understanding of the acronym. Okay? Failure to enroll rate, or FTE or FER. Okay? This measures how often the system fails to create a template during the enrollment process. Maybe you have a low quality input, like a smudged fingerprint or poor lighting. Maybe you have hardware limitations. Maybe the user's physiological traits don't scan well, right? For example, if you're taking a Pearson VUE exam and you're going to a testing center, they want to take your photo. Usually they'll have you take off your hat, they'll have you take off your glasses because those will possibly give you erroneous data points, right? A high FTE means that we have a poor onboarding experience. Failure to capture rate, FTC. This is going to measure how often a system fails to detect biometric input during the authentication process, not the enrollment process. All right, this is pretty common in automatic systems like facial recognition, or if you're doing gait analysis, maybe there's sensor misalignment, maybe there's some sort of environmental interference, maybe the user's not standing still, or there's some sort of obstruction. And then we finally have template capacity. What is the maximum number of biometric templates that system can store? This is pretty critical for things like scalability, especially if you have a large enterprise and you have a multi-tenant environment. It can also impact things like the performance of the system, the retrieval speed of the system, and so on. So now I've got a company that decides to implement fingerprint scanning for building access. FTE matters during the onboarding. If 10% of the employees can't enroll, you have to have some sort of fallback method. FTC is going to affect the usability, right? If the scanners fail during rush hour, that can cause bottlenecks and delays. And then the template capacity, we need to be able to have a solution that's going to support all of the employees, contractors, visitors, and we also need to have room for growth. Okay? So we use these variables to evaluate vendors, to tune our systems, to design fallback workflows if for some reason the primary workflow is not available. Okay, fingerprints, tried and true method, old method, simple method, right? Fingerprints work well because they're unique, they're stable, and they're very detailed. Very, very good biometric identifier. Most laptops, mobile devices include some sort of fingerprint scanner for secure access. Fingerprint recognition analyzes things like whorls, loops, arch patterns, which is distinct and unique to each individual. Those patterns are formed by ridges and valleys, and these will usually stay consistent over time. All right? What are some of the advantages of using fingerprints? Number one, they're always available. Unlike passwords, you don't forget your fingerprint. They're pretty static, they're pretty persistent. We don't have to rotate or update credentials. They are also difficult to alter. Now, they can be altered, right? If you're in a horrific car accident and suffer third-degree burns across your hands and feet, that might alter your fingerprints. That's pretty gruesome, but all right. There are some vulnerabilities, though, with fingerprints, and certainly some operational concerns that we have. Number one, you can have residual prints. Natural oils in your hands or fingers, they can leave residue on scanners, and that residue can be lifted off. There is also a potential for spoofing. You can use photocopies, you can use molds to trick scanners, especially if they're low quality scanners. Then of course there's hygiene as well. Not hygiene in terms of germ transfer, although some people consider that. It's more about like, are there smudges or dirt that's going to result in some sort of false rejection or some sort of degraded performance. All right. Users need to scan multiple fingers so that we can create a robust template. Usually authentication is going to be multi-factor. So you're going to do your fingerprint plus you'll put in a PIN code. And if the scanner fails, you can revert to something like token or password-based authentication. You have to balance convenience versus risk, especially in highly sensitive environments. That's why almost always we'll combine fingerprint biometrics with liveness detection, multi-factor authentication, and certainly audit logging. Absolutely. All right. Iris scanning, mathematical pattern recognition technique on video images on the iris with unique and stable complex patterns that can be seen from a distance. So iris scanning analyzes the texture of the iris, the coloring around the pupil, the visual part of the eye. We can actually use near infrared light, which can help enhance the visibility of those patterns, even if you have low light conditions. And then algorithms will convert those patterns into a digital template. Highly, highly stable. The iris, for the most part, remains unchanged throughout your life. Facial features, wrinkles, scars, blemishes, that will happen, right? Fingerprints even, well, they don't change that much. They could, right? Hands get wrinkled and stuff like that. Very fast, very accurate. Pretty low false match rates. And pretty quick processing kind of makes it ideal for high throughput environments. There's also no physical contact. Scanning happens at a distance. So now we don't have hygiene concerns, and the reader can't get damaged or dirty or whatever. There are some limitations though. Sudden changes in light or glare can disrupt the scans. You could have pupil dilation, the emotional state of an individual, whether they're taking medication or quote-unquote medication. The lighting can alter the pupil size. It can distort the shape of the iris. You also have this proximity requirement. The eye has to be close enough so that you can clearly see it, which is not always ideal in all user environments. Even think about the idea that humans are different sizes and shapes, right? You have to have a scanner that can work with somebody that's 6'5" or 4'2". All right. Still pretty common though. Still pretty common. Different than a retina scan. All right, we'll talk about a retina scan on the next slide here, but retina scans are the back blood vessel pattern of the eye. Iris scan is the visual part of the eye. Okay? Why does near infrared matter? Most people have dark brown eyes because they have a lot of melanin. Dark brown absorbs visible light, which hides the texture of the eye. Near infrared, which is 700 to about 900 nanometers, penetrates that melanin better. So it's still going to reveal the iris's structure even if you have dark eyes. Near infrared also reduces glare from the cornea, which is that specular reflection that you see. That's also going to improve your scan accuracy. So a camera basically captures the iris using that near infrared illumination. We extract those texture patterns, rings, furrows, crypts, and then we convert them into a digital template. All right? Now on the left we see visible wavelength. The iris texture could be kind of hard to distinguish because of melanin or ambient light glare. Near infrared, the iris feature becomes a lot more visible even if you have dark brown eyes. And if we do the extracted structure, we're processing the image to highlight the biometric features, and that's what we can use for matching. Now, what about retina scanning? This is a biometric technique that uses unique patterns on the retina blood vessels, not to be confused with iris recognition, which is the visible part of the eye. It's the unique pattern of the blood vessels in the retina, right? That's the neural tissue at the back of your eye. Unlike iris recognition, which scans the surface texture, retina scanning maps the vascular structure, which is genetically determined and extremely stable. So we have a low energy infrared beam directed into the eye. The blood vessels will absorb light differently than the tissue that surrounds the blood vessels, and that's what creates that distinct reflection pattern. That pattern then gets digitized and stored as your biometric template. Very, very precise method. Probably second to only DNA in terms of reliability. Also highly stable over time. Believe it or not, the pattern pretty much remains unchanged from the time you're born to the time that you pass on. Of course, it's also extremely hard to spoof. You have to look at the live tissue. So there's a liveness element to this as well. Okay? Some limitations do exist. Right? If you have medical conditions like glaucoma or diabetes, that can alter the patterns. Users might not feel as comfortable with it as well because you have close contact. It can be kind of invasive. And it's very, very environmentally sensitive. Lighting and eye can affect the scan quality. All right. Also, in addition, the scanning tools can be a little bit expensive compared to some of the other options that we have. All right. So we kind of already talked about this, but we'll just summarize it really quickly. Low occurrence of false positives, extremely low, almost 0% false negative rates, which is really a huge benefit, right? Which means we have strong reliability. No two retinas are alike. The patterns remain consistent over your lifetime, and very, very fast matching. Disadvantages: conditions like cataracts, astigmatisms, retinal disorders. Those can distort the scan results. Scanning is perceived as a little bit invasive because it requires close proximity to the optics, which is not ideal for like a casual environment or a high volume use case. And specialized infrared imaging equipment can be really expensive. There's also health and safety concerns. Poor quality devices could actually cause damage or eye strain or headaches or whatever it might be. Okay? Voice print. Hello, my name is, my voice is my passport, verify me. I don't know if you guys are movie people. That comes from an old movie called Sneakers. And they were trying to break into an office. Okay? Basically, voice print means the user speaks a specific phrase. We compare the waveform to what's stored. The goal is to match the vocal patterns. But not just the vocal patterns, pitch, cadence, frequency, but it can be easily duplicated. Voice recordings, as you can see from the diagram, could be captured and replayed. Sneakers. Very real. Voice variability, illness, stress, aging, even, yes, your mood, can alter your voice characteristics. That kind of makes consistency a challenge in that regard. Environmental noise can cause a problem. Background sounds during the enrollment or authentication could distort the template, and that will ultimately reduce accuracy. It's very difficult to verify that the speaker is alive and that the input is not a replay. Even nowadays, we add the concept of deep fakes and artificial intelligence. It's even crazier now, right? Audio editing tools, artificial intelligence, they can impact the accuracy, or the reliability, I should say. Pretty common method is hand geometry scanner. I'm sure you guys have seen these biometric devices in the past. This relies on the way the hand is shaped, right? The lengths, the widths, the angles of the fingers and the palm. We use geometric features to match a scan against a template. It doesn't rely on vascular patterns. It doesn't rely on fingerprints, just shapes and proportions. Pretty non-intrusive, pretty user-friendly, very easy to use, minimal discomfort, fast throughput, great for physical access control. This is actually the kind of scanner that we would have used to gain access to the data center when we had our hosted data center stuff. Also very effective in two-factor setups. You got the keypad, you have to put in your PIN code, which is something you know, and then you put in your hand for the geometry scan, that's something you are. It's also very durable against surface wear. Fingerprints, hand geometry, different, right? Hand geometry isn't affected by cuts, by dryness in the skin, by surface contamination. All right? The only, I guess, primary limitation would be hand shapes aren't highly distinctive. So you could have a higher false acceptance rate compared to something like an iris scan or retina scans. It's also really not ideal for large populations or used in really high secure environments because it doesn't have a lot of discriminatory power. And it also requires physical contact. So again, hygiene, wear and tear can affect the speed of authentication if you're worried about hygiene. Palm vein scanning. Well, vein scanning in general. Usually it's a palm, but it could be an arm or a leg or something. But usually it's a palm because that's just hold your palm over the scanner, right? This uses infrared light, much like the retina scan, to map the unique patterns of blood vessels underneath your skin. Could be the back of your hand, it could be your palm, whatever. This is going to capture that branching structure of veins, which again is stable over time. Very, very difficult to replicate. You don't have to touch the device, you just simply hold it above the device. So this is ideal for environments where hygiene is a concern, durability of the scanner is a concern. It's kind of unaffected by surface conditions. So even if the skin is dry, if you have dirt on your hands, if the skin is abraded, it will not affect the scan because it's infrared. It's not based on like a fingerprint. Very fast, very reliable. Scans typically complete in half a second or something like that. And also an element of liveness, right? Very, very difficult to forge. Because they're not visible to the naked eye. Plus, you have to have kind of a pulse in order for it to work. Still kind of emerging. Not yet a standard. It does require specialized hardware. When you guys go and take your CISSP exam, you go to a Pearson Professional Center, you will have to capture a palm vein scan. I did when I took my exam. It's also not universally trusted. Some people still think this is kind of an experimental thing. It's not really mainstream. Okay? All right. Compared to a retinal scanner, which is more accurate than a vascular scanner, retinal scanners have much lower popularity because of their intrusive nature. All right? Retinal scanning provides pretty much the highest level of precision. They're stable, they're unique. But again, perceived as invasive. Users may feel discomfort exposing their eyes to a light source. It also is very complex. It requires lots of calibration for height, for face alignment, for lighting. It's not really a plug-and-play solution. Vein scanning, internally stable like retina scanning, hard to replicate, excellent biometric measurement. There really is no known method to forge a palm vein scan, like a voice print or a fingerprint. It's contactless. It's seemingly non-invasive because it's done with your hand and not your eyes. And it's generally easy to deploy. If you want maximum accuracy, and accuracy is non-negotiable, retinal scan. intelligence agencies, nuclear facilities, those kinds of places. Vein scanning does hit that little sweet spot, though. It's user-friendly access control. Things like healthcare, finance, clean room environments, they might use this. Both offer very, very strong biometric traits, but the choice of what you decide to use will depend on your risk tolerance, user population, and whatever operational constraints might exist. Another component that we can measure is something called signature dynamics. Signatures, or a signer writes out their handwritten signature on an electronic pad, such as ePad by Interlink or Palm Pilot. All right? We're not just capturing the shape of the signature. We're capturing the pressure applied by the pen, the speed and the rhythm of the writing, the stroke sequence, right? How did the T get crossed? When did the I get dotted? It's pretty amazing when you think about it. You think, well, a signature is just a signature, right? But those dynamics create this behavioral biometric profile. This allows us to mimic traditional signing. We don't really have to have any technical knowledge. There's no specialized training, but it goes beyond a static image. It captures how the signature is made, not just what it looks like. This will help people like notaries and systems detect differences between a genuine signature and a forged signature. All right? There are some limitations, though. Signatures can vary over time. Fatigue, stress, injury, that can change how you sign. What if you break your right arm and you're right-handed, and now you have to sign with your left hand? Yeah, you probably have to re-enroll because the dynamics are going to be completely different. It's also very sensitive to different environments. So you have to do device calibration, you have to select the right pen type, the right writing surface. It does lower uniqueness compared to physiological biometrics. For example, it's not as distinctive as a fingerprint or your iris pattern. So it's really, signature dynamics would primarily be used for supplemental authentication. Keystroke dynamics, similar concept. Keystroke dynamics or keyboard dynamics looks at the way the person types on a keyboard using different keystroke rhythms. That makes sense? So it tracks how the person types, not just what they type. We have a typing profile. What's the dwell time? How long do I stay on each key, or how long is that key held down? What's the flight time? The time between releasing one key and pressing the next key. What is the latency and the rhythm? This is the overall cadence, the hesitation, the transitions. This can form a biometric template. It's kind of subtle, but it is distinctive. Now, I will say, I get very used to my keypad on my laptop because you use it all the time. When I go to another computer that has a different tactile feel, a different shape of the keyboard, a different size of the keyboard, that can definitely affect the dynamics. But the strengths are it runs in the background. We can run this in the background. We don't have to interrupt the user. If we want to continually do ongoing identity assurance, we don't really need any hardware because it works with just your standard keyboard. Very low cost. Pretty hard to imitate. Typing rhythm is kind of subconscious. So it's difficult to impersonate because it's also difficult to observe and collect. You want to observe somebody's typing rhythm. Very useful for insider threat detection. Deviations from baseline typing behaviors could flag account misuse or maybe possibility credential sharing, something like that. But it can also vary over time. Like I said, fatigue, stress, injury, that can change your typing rhythm. Then you get false rejections. Environmental sensitivity, keyboard type, the keyboard layout, your posture. Are you standing? Are you sitting? All right. It's also not as unique or stable as a physiological biometric. So again, another element used as a supplementary factor, not a primary factor. What is accountability? It is the backbone of security assurance, right? Accountability means that every action in the system can be traced back to a responsible entity. Could be a human, could be a process. It's about answerability. Who did what, when, and with what impact? The core pillars of accountability include identification and authentication. You have to know who is acting before you can hold them accountable. So you have to have strong credentials. You have to have multi-factor authentication. You have to have an identity lifecycle management system foundationally provides for that accountability. You have to have auditing and logging. Every meaningful event should be recorded, time-stamped, and attributed to a user. Logs have to be comprehensive. They have to be timely. They have to be tamper-resistant. We also need to make sure that we're tracking sessions. We want to track users' activity across time. We want to prevent session hijacking. We want to support forensics, forensic analysis. There has to be an element of non-repudiation. We talked about that in domain number 3. That means that a user cannot deny actions that they performed. We achieve this through digital signatures, secure logs, cryptographic integrity. We have to have organizational culture which drives organizational policy. Policies have to be built to enforce accountability, and the culture must support it as well. So that includes training, awareness, leadership behavior. All right? Without accountability, there's no way for you to prove misconduct. There's no way for you to enforce policy. There's no way for you to recover from breaches. You lose trust from regulators, from customers, from internal stakeholders. With accountability, you have auditability, you have compliance, you have reliance, and that reduces the overall insider threat risk. All right? It's a general concept, but it's a very, very important concept. Stronger identification. For accountability to be successful, actions have to be attributed to a single individual, a process, a device, an object, etc. Without the ability to directly associate an action with an individual, repudiation of that action can arise. All right? Every action has to be attributable to a single entity. Doesn't have to be a person, could be a process, could be a device, could be an object. Reputed actions meaning denying responsibility and undermining trust in that element, right? Shared accounts are a problem. Prime example of weak identification. Multiple users have access to the same credentials. The logs show the activity, but it's considered to be done with generic identity. There's no way to pinpoint who did what. So what does that create? That creates plausible deniability. Users could blame others for unauthorized actions. Okay? Strong authentication. Weak authentication makes it easier for an attacker to take control of accounts with no accountability and allows users to blame weak authentication on account abuses. If authentication is weak, simple passwords, no multi-factor authentication, attackers can hijack accounts with really no resistance. All right? Users can exploit those weaknesses also. They can blame poor security controls for misuse, for unauthorized access. The result of that is no accountability, no non-repudiation, basically a wide open door for plausible deniability. Strong authentication is the enforcer, right? That links access to something only one individual possesses. Biometrics, smart card, token. That tight coupling ensures non-repudiation. Users cannot credibly deny actions taken under their identity. So if you pair this with strong identification, that's going to create a high integrity audit trail. All right. User training and awareness. Users need to be trained and have basic awareness of the penalties of misuse of accounts, information, and systems. Informed users are less likely to do things or abuse things, right? Users have to understand the rules of engagement. What is allowed? What's risky? What are consequences? When a user knows the penalties for misuse, they're less likely to intentionally abuse access, they're less likely to make careless mistakes, and they're less likely to be able to claim ignorance if they get caught. Repetition builds resilience. One-off training doesn't typically fit the bill, right? You have to have structured, recurring training programs that's going to reinforce behavior. You have to have reinforcement tools like login banners to give you those little reminders, right? This system is being monitored. Unauthorized use may result in disciplinary action. These messages kind of indicate or provide directives for users to act in a responsible way, even as they log in. All right? Monitoring. Monitoring must be sufficient to detect problems and violations with accounts, with access, with information egress, and system operation. All right? Without monitoring, you're kind of flying blind. There's no way to detect misuse. There's no way to detect violations or system anomalies. Visibility is absolutely imperative for accountability. If you can't see it, you can't prove it. And you definitely can't respond to it. So we will use monitoring tools like data loss prevention, which detects and prevents unauthorized data exfiltration, intrusion detection systems, which alert on suspicious activity, intrusion preventative system or prevention systems, which actively block known threats, firewalls, which allow us to control traffic flow and enforce perimeter boundaries. They're not plug and play. They have to be strategically deployed to cover internal flows and external flows. All right? Let's say a user uploads sensitive customer data to a personal cloud storage device. If I don't have DLP, nobody's going to notice. But with DLP and logging, we can flag that transfer, we can alert security, we can tie that event to a user's identity. Now we've got non-repudiation, we've got incident response, We've got policy enforcement, all because monitoring was in place. All right? We have to align monitoring with business risk. Make sure that logs are actionable, not just noisy. We also need to balance internal and external visibility because insider threats are just as real as external threats. All right? Audit logs. These are necessary in if event actions have to be traced back to a user. All right? Audit logs are basically the proof. They're not just records, they're a narrative. Who accessed what, when it happened, what was changed, what was moved, what was deleted. A DLP, like I said, that can identify exfiltration attempts, intrusion attempts, and block threats with IPS and IDS, server logs, file access, system changes, file integrity monitors. Firewalls can monitor for traffic flows, port scans, rule hits against rules in the firewall. All these logs should be centralized into a security, information, and event management system, the command center for your correlation and analysis. All right? Independent audits. Independent audits help assure accountability by bringing in an unbiased third party to review accounts, actions, and impacts. Right? Internal controls can be strong, but typically internally we have bias. We might have blind spots. We could have collusion, and that can undermine accountability. Independent audits bring in a neutral third party so we can review accounts and actions, validate impacts and outcomes, and it ensures transparency and ethical alignment. Why are these critical? Right? Why are these critical? If there's suspected collusion between insiders, internal logs and monitoring could be compromised. It could be important for regulatory requirements, SOX, HIPAA, GDPR. Independent audits are typically required for that. There's also a cultural tone setting. Audits can signal to individuals corrupt practices are not going to be allowed, right? So that's a important concept. Policy and organizational behavior. Organization policy must recognize the need for accountability, right? We're setting expectations for behavior. There have to be sanctions for violations. There have to be rewards for integrity. Without policy, enforcement is inconsistent. It becomes subjective. The most powerful element in accountability is not actually technology. It's the culture of the organization. If violations are met with timely, consistent consequences, that means you're telling employees, you're telling contractors, you're telling business partners, accountability is non-negotiable. Integrity is integral. All right? I mean, these are general concepts, and we've already hit on this in other domains. But, you know, in the principle of this exam, really, really key elements. All right? Why do session management elements matter? The lifetime or lifespan of access. All right? We've started to see everything kind of moving to web applications, to cloud platforms. It's not just about the login. It's about how long, how broadly does that access remain? Does that access persist? So session management instructs or governs how authentication is maintained across different resources. how sessions are tracked, how they're isolated, how they're terminated, right? We have desktop session managers, which allows multiple concurrent sessions with different applications and files, but there is a risk of cross-session leakage or privilege confusion in that scenario. We have web browsers that use things like cookies or tokens and headers to maintain sessions, but those are vulnerable to things like hijacking, fixation, or replay attacks. All right? A lot of systems support multi-session environments. It gives us flexibility, but it requires much better controls. Imagine a user logs into a cloud dashboard and they use a single sign-on. Their session token gives them access to multiple microservices that might exist in the cloud. If that token isn't scoped properly, or if it doesn't have an expiration, it becomes a persistent attack surface. So attackers could hijack that session, they could steal the cookie, replay the tokens, which means that they're now able to bypass authentication entirely. All right? So we should have short-lived tokens, different refresh mechanisms. There should be adequate session timeout policies based on risk signals or inactivity, secure cookies, token binding, context-aware session validation should also be included as well. Timeouts and automatic logouts. Most operating systems have at least some sort of screensaver functionality. All right, I don't know, we don't really use screensavers these days, but similar concept, right? Screensavers weren't originally designed for security, right? They were designed for CRT burn-in. That was kind of a hardware concern. But over time, they've kind of evolved into either an energy saving tool or a security function by locking out idle sessions. All right, timeout-based session locks protect walkaway risk. Clearly, when a user leaves their workstation, they don't log out. We need to be able to protect against that. So we automatically lock the session after a period of inactivity. That's still going to preserve the user's work, but it's going to prevent unauthorized access to that workstation. If you have a shared environment or a high traffic environment like a hospital, a call center, a security operations center, you would be concerned about that. Okay? Session logon limitations. Session and logon limitations focus on usability and the security trade-offs. All right, example, a company has highly mobile workforce and they may want to consider allowing multiple sessions from the same username. All right, on one desktop, you can have tasks running, then you can go to a laptop for remote work or whatever. Of course, that's going to help with productivity, but then now each of those active sessions becomes a potential entry point for your attackers. So more sessions amplifies risk because you're going to have more credentials in memory, you're going to have more endpoints to monitor, more chances for session hijacking, token theft, lateral movement, especially in virtual desktop environments where session isolation might be specific, right? Might be a strong consideration. Okay? If I have two active sessions, one at the headquarters and one at home, if a third session pops up from overseas IP address at, say, 3 a.m., that could indicate a red flag, right? Impossible travel time, non-normal work hours, that kind of thing. Behavioral analytics could detect that anomalous login pattern, and that could trigger an alert. That could step up authentication, all right? Typically, we want to limit concurrent sessions based on the role of the user or the risk of the user. We want to monitor session behavior for outliers in normal activity. And then we also want to tie sessions activity back to some sort of We talked about this in the previous slides. Strong identification and authentication. All right. We might have schedule limitations. Pretty obvious what they're talking about here, right? Limit sessions based on time. All right. Access isn't about who or what, it's also about when. That's part of the context. By limiting session creation to a specific time window, we can reduce the exposure during off hours, opportunities for unauthorized access during those times, and our attack surface from idle systems or unattended systems. All right. For example, a kiosk might be only available during business hours so that there's no misuse after hours. A cash register may require off-hours access if you're doing reconciliation and maintenance, but you need to make sure that that's documented in the policy. Virtual desktop sessions are restricted to working hours unless they're explicitly authorized for after-hour tasks. These controls are what we call mission-aligned controls, granting just enough access for just enough time to get the job done. Pretty simple concept to understand. Registration and proof of identity. Identity proofing process is the process of collecting and verifying information about an individual. All right? Before a user can be authenticated, their real-world identity needs to be verified. That's what identity proofing is. It makes sure that the person requesting access is truly who they claim to be. It could be collecting different artifacts, like a driver's license, a passport, a birth certificate, a government ID. It can include different verification methods, like in-person validation, remote verification through trusted third parties. The depth that we apply, I guess they call that rigor, right? Depends on the certification policy. What is the sensitivity of the access that we're granting? So a user gets issued a digital certificate so that they can access a government portal. Right. First thing, we have the initial registration. We need to make sure that the full identity proofing, in-person validation, multiple documents, background checks, all that's done. And then for subsequent logins, we rely on the credential that gets issued. We don't have to repeat that full process again. Now, if the credential expires, or maybe the user's privileges level gets elevated or demoted or whatever, then we might have to go through that process again. E-authentication, electronic authentication, is the process of establishing confidence in the user's identities electronically presented to the information system. All right. Basically, we're trying to establish confidence that the person or the entity that's presenting the credential is the legitimate holder of that credential. It's not just about logging in. It's about validating trust every time we have access. How do we do that? We use something you know, password or a PIN. We use something you have, smart card, token, something you are, fingerprint, face scan, iris scan. We typically will use 2 or more factors, multi-factor authentication. That's going to increase assurance. That's going to reduce the risk of compromise. Good stuff to know. All right. Now, you will probably be asked about governance, right? We talked a lot about governance in Domain 1, a little bit in Domain 2, right? Governance, it comes in a lot of different forms, but FIPS 201-2, which is the Federal Standard for Identity Assurance, Every federal agency is responsible for verifying and validating the identity of individuals and their credentials. So FIPS 201-2 actually defines all of the technical and procedural requirements for binding something like a PIV, personal identity card, verification card, to the verified entity, right? We're trying to create this chain of trust. It goes beyond just standard identity proofing. It goes to credential issuance to authentication. PIV1 defines identity proofing and registration requirements. PIV2 covers credential assurance, lifecycle management, and the technical specifications. Regardless, both of these ensure that the identity is validated and managed across agencies. So a federal agent gets a PIV card. Their identity gets validated using government-issued documents. That card gets issued under strict controls. When you access the federal system, that card then becomes a trusted credential which works across multiple agencies. This is why in the body of knowledge we emphasize governance frameworks. All right, we're not just verifying once, we're providing continuous trust across different organizations. All right, so chain of trust is what we're talking about. That's where we left off on the last slide. Technology itself doesn't actually mean trust. All right, we can have the most advanced credentialing mechanisms, smart cards, biometrics, everything else that we talked about. But if there's no identity proofing behind that, right, it kind of makes it a little bit useless. So the trust in this case is about the process. It's not just about technology. 201-2 describes that process. All right, we have different identity vetting rules. And by going through those different steps, we can accept credentials that are issued by others. We don't have to have credentialing duplications. We can maintain interoperability and trust across a lot of different systems. We talked about this term previously, right? It is kind of like federated identity, but it's federated identity at a large scale. All right? If a federal contractor gets vetted, they get issued a PIV by, let's say, an agency, right? Could be FBI, CIA, whatever. Then they go and they do work with another agency. Because both of those agencies follow the 201-2 standards, we can actually, that new agency can now trust the credentials. They don't have to go through the whole identity proofing process again. All right? That's going to save a lot of time. We need to make sure we align our identity proofing with policy, assurance levels. We need to enable credential portability, meaning we can move these credentials or use these credentials in different environments. All right? Trust gets validated, it gets preserved based on the credentialing life cycle that we're implementing. All right? Now, the last couple of slides I threw in here, we only have a couple of slides left in this section, and then we'll wrap up this video. Not something you necessarily need to know for the test, but I thought it was relevant, right? About kind of how agencies work and so on. We use approved identity proofing and registration processes, right? The National Agency Check with Written Inquiries, NACI. or some sort of equivalent investigation, whatever that might be, right? National security investigation or OPM or whatever. For current employees, if they already have an NAC file, right, that would typically satisfy the requirement. What are some of the steps that we'll take before we actually issue credentials? I might do an FBI fingerprint check. I might do in-person appearance, right, before I issue the PIV card, right? There's no remote onboarding, in other words. I could do document verification, right? You have to have original source documents. They mentioned I-9 or OMB number 1115 here, but dash 0136, but you don't need to know that for the test. But one ID must be valid, unexpired, that's issued by a state or federal government. Okay? PIV identity proofing registration issuance process must adhere to the principle of separation of roles. No single individual may have the power to request the issuance of a PIV credential without the approval of a second authorized person. All right? In other words, one person cannot perform multiple roles. The only exception to that is the issuer and the digital signatory. Those two can be combined together under this principle. What is the purpose here? We're trying to reduce the risk of collusion between the applicant and the issuer. Okay? Safeguards against the possibility of collusion between the applicant and the issuing party. So these are some of the defined identity proofing roles. I doubt again that you'll see this on the exam, but we'll go through it really quickly and we'll wrap up this video. Okay, the applicant, that's who's obviously requesting the PIV credential. They're the ones that have to undergo the identity proofing. They have to undergo the background checks. And that credential is issued only after the PIV registrar approves that based on the identity proofing. The sponsor is the individual or organization that's validating the need for the credential. They're the ones that typically initiate the application process, and they provide the business justification to get the credential. The registrar themselves are the ones that are doing the identity proofing. They're doing the background checks. They're making sure that everything is processed. They're also the ones that have the final approval authority before they actually issue the credential. They don't do the issuance, but they have that final approval. All right. If all the requirements get met, then they go to the issuer, and the issuer issues the credentials, and they handle all the physical and digital provisioning of the PIV card and so on. A digital signatory signs the biometric and the cardholder unique identifier, the CHUID, and that makes sure that the credential is cryptographically bound to the entity. And then finally, we have the PIVCA, the certificate authority. These are the individuals that sign and issue the authentication certificates. They also enable the credentials to be used for secure access across different systems. All right. All right, so that is the conclusion of this section. We have one more section before we wrap up the domain, so we'll see you guys in